We'll come back. Let's read this one.
CFM International Leap. The CFM International Leap, leading edge aviation propulsion, is a high bypass turbofan engine produced by CFM International, a 50-50 joint venture between American GE Aerospace, formerly GE Aviation, and French Safran Aircraft Engines, formerly Snecma. It is the successor of the CFM56 and competes with the Pratt & Whitney PW1000G to power narrow-body aircraft. Design, edit. The Leap's basic architecture includes a scaled-down version of Safran's low-pressure turbine used on the GEnx engine. The fan has flexible blades manufactured by a resin transfer molding process, which are designed to untwist as the fan's rotational speed increases. While the Leap is designed to operate at a higher pressure than the CFM56, which is partly why it is more efficient, CFM plans to set the operating pressure lower than the maximum to maximize the engine's service life and reliability. Currently proposed for the Leap is a greater use of composite materials, a blisk fan in the compressor, a second-generation twin-annular premixing swirler, TAPS 2, combustor, and a bypass ratio around 10-11-1. The high-pressure, HP, compressor operates at up to a 20-1 compression ratio, which is roughly double the corresponding value for the CFM56's HP compressor. CFM uses ceramic matrix composites, CMC, to build the turbine shrouds. These technological advances are projected to produce 16% lower fuel consumption. Reliability is also supported by use of an eductor-based oil cooling system similar to that of the GEnx, featuring coolers mounted on the inner lining of the fan duct. According to Aviation Week's article, the eductor device produces a Venturi effect, which ensures a positive pressure to keep oil in the lower internal sump. The engine has some of the first FAA-approved 3D printed components. Development, edit. The Leap, leading-edge aviation propulsion, incorporates technologies that CFM developed as part of the Leap 56 Technology Acquisition Program, which CFM launched in 2005. The engine was officially launched as LeapX on the 13th of July 2008. It is intended to be a successor to the CFM 56-5B and CFM 56-7B. In 2009, Comac selected the Leap engine for the C919. The aircraft was due to begin testing in 2016. In total, 28 test engines will be used by CFM to achieve engine certification, and 32 others will be used by Airbus, Boeing and Comac for aircraft certification and test programs. The first engine entering the test program reached and sustained 33,000 lbf, 150 kN, of thrust, required to satisfy the highest rating for the Airbus A321neo. The same engine ultimately reached 35,000 lbf, 160 kN, of thrust in test runs. CFM carried out the first test flight of a Leap 1C in Victorville, California, with the engine mounted on the company's Boeing 747 flying test aircraft, on the 6th of October 2014. The -1C version features a thrust reverser equipped with a one-piece O-ring replacing a two-piece door. The thrust reverser is deployed by the O-ring sliding aft, reducing the drag that was induced by the older design and improving efficiency. In April 2015, it was reported that the Leap 1B was suffering up to a 5% shortfall on its promised reduction in fuel consumption. It obtained its 180-minute ETOPS approval from the U.S. Federal Aviation Administration and the European Aviation Safety Agency on the 19th of June 2017. Orders, edit. On the 20th of July, 2011, American Airlines announced that it planned to purchase 100 Boeing 737 aircraft featuring the LEAP-1B engine. The project was approved by Boeing on the 30th of August, 2011, as the Boeing 737 MAX. Southwest Airlines is the launch customer of the 737 MAX with a firm order of 150 aircraft. The list price of a LEAP-1A is $14.5 million and $14.5 million for a LEAP-1B. CFM International offers its support for the engine, and signed a 15-year rate per flight hour agreement with Long Air for 20 LEAP-1A at US $333 million, or $3,039 per engine per day, in contrast with US $138 million for 17 CFM International CFM 56 over 12 years or $1,852 per engine per day. As a number of a 320neo engine for ANA Group of Japan was also ordered in 2014, there is a possibility to select the LEAP engine. In 2016 CFM booked 1,801 orders. LEAP backlog is at more than 12,200 for more than $170 billion US at list price. In early 2018, the backlog was at 14,500, with a 59% share of the A320neo market for decided customers, as it has an 18 percentage point advantage in utilization rate over the Pratt & Whitney PW1000G. By July 2018, the LEAP had an 8-year backlog with 16,300 sales. More LEAPs were produced in the 5 years to 2018 than CFM 56s in 25 years. It is the second most ordered jet engine behind the 44-year-old CFM 56, which achieved 35,500 orders. In July 2018, its A320neo selected engine market share was 58.6%, with one-third yet to select. The CFM 56 have a 60% share of the A320ceo market. In 2020, GE Aviation lost 1,900 orders worth $13.9 billion, $7.3 million each, reducing the backlog value to $259 billion. While more than 1,000 Boeing 737 MAX orders were cancelled among the Boeing 737 MAX groundings and the impact of the COVID-19 pandemic on aviation. Production, edit. In 2016, the engine was introduced in August on the Airbus A320neo with Pegasus Airlines, and CFM delivered 77 LEAP. With the 737 MAX introduction, CFM delivered 257 LEAPs in the first 3 quarters of 2017, including 110 in the third, 49 to Airbus and 61 to Boeing, and targets 450 in the year. CFM was to produce 1,200 engines in 2018. 1,900 in 2019, and 2,100 in 2020. This is compared to the 1,700 CFM 56 produced in 2016. To cope with the demand, CFM is duplicating supply sources on 80% of parts and even subdivide assembly sites, already shared between GE and Safran. GE assembles its production in Lafayette, Indiana, U.S. in addition to its previous Durham, North Carolina, U.S. facility. As more than 75% of the engine comes from suppliers, critical parts suppliers pass run rate stress tests lasting 2 to 12 weeks. Pratt & Whitney acknowledges a production ramp-up bottleneck on its rival PW1100G geared turbofan, including a critical shortage of the unique aluminium-titanium fan blade. hitting the Airbus A320neo and the Bombardier C-Series deliveries. Safran assembles its production in Villeric, France. Safran and GE each assemble half of the annual volume. Mechachrome plan to produce 120,000 130,000 LEAP turbine blades in 2018, up from 50,000 in 2017. In mid-June 2018, deliveries remained 4 to 5 weeks behind schedule, down from 6, and should catch up in the fourth quarter as the quality variation of castings and forgings improves. The production has no single manufacturing choke point by selecting multiple suppliers for every critical part. From 460 in 2017, 1,100 LEAPs should be built in 2018, along 1,050 CFM 56s as it encounter unexpected sales, to pass the record production of 1,900 engines in 2017. It will stay over 2,000 engines per year as 1,800 LEAPs should be produced in 2019, while CFM 56 production will drop, then 2,000 in 2020. In 2018, 1,118 engines were delivered. Over the first half of 2019, CFM revenues were up by 23% to €5.9 billion with 1,119 engine deliveries, declining sales of CFM 56, 258 sold, more than offset by LEAP, 861 sold. Recurring operating income rose by 34% to €1.2 billion. But was reduced by €107 million, $118 million, due to the negative margins and initial costs of LEAP production, before a positive contribution expected in the second half. Revenues should grow by 15% in 2019, but free cash flow depends on the return to service of the grounded 737 MAX. In 2019, LEAP production rose to 1,736 engines. Orders and commitments reached 1,968 amid the 737 MAX groundings, compared with 3,211 for 2018, for a stable backlog of 15,614, compared to 15,620. CFM expects to produce 1,400 LEAP engines in 2020, including an average of 10 weekly LEAP 1Bs for the Boeing 737 maximum. By March 2022, CFM intended to output 2,000 engines in 2023, up from 845 deliveries in 2021. In 2023, CFM booked over 2,500 orders, resulting in a backlog of 10,675, delivered 1,570 LEAP engines, up by 38% from 1,136 in 2022, and was expecting 20 to 25% more deliveries for 2024. A durability kit for hot and dusty conditions was planned as the LEAP was selected for 75% of the A320neo orders due to the troubles of the competing Pratt & Whitney GTF. Operations, edit. The troubled introduction of the PW1100G on the A320neo has motivated customers to choose LEAP engines. LEAP market share rose from 55% to 60% in 2016, but orders for 1,523 aircraft, 29%, had not specified which engine would be chosen. From January through early August 2017, 39 PW1100G engines versus 396 CFM LEAP engines were chosen. As an example of PW1100G reliability issues, 9% of LEAP-powered A320neos were out of service for at least 1 week in July 2017, compared with 46% of those using the PW1100G. The Boeing 737 MAX LEAP-1B started revenue service in May 2017 with Malindo Air with 8 hours of daily operation, while the A320neo LEAP-1A surpassed 10 hours per day by July. Safran discovered a production quality defect on LEAP-1B low-pressure turbine discs during assembly for possibly 30 engines, and CFM is working to minimize flight test and customer delivery disruptions. In early October 2017, an exhaust gas temperature shift was noticed during a flight, and a CMC shroud coating in the HP turbine was seen flaking off in a borescope inspection, creating a leaking gap. 8 in-service engines are seeing their coating replaced. Safran provisioned €50 million, $58 million, to troubleshoot in-service engines, including potentially LEAP-1B S40 LEAP-1A were replaced, and the part should be replaced in over 500 in-service engines, while shipments are 4 weeks behind schedule. Deliveries with the permanent CMC environmental barrier coating fix began in June. On the 26th of March 2019, due to the Boeing 737 MAX groundings, Southwest Airlines Flight 8701, 737 MAX 8, took off from Orlando International Airport for a ferry flight to storage without passengers, but soon after problems with one of the engines caused an emergency landing at the same airport. Southwest then inspected 12 LEAP engines, and 2 other airlines also inspected their engines. CFM recommended replacing the fuel nozzles more often due to coking, a carbon buildup. By December 2021, CFM claimed a 72% share of the narrow-body market. Applications, edit. CFM International LEAP engine. Model application thrust range introduction. -1 Airbus A320neo family 24,535,000 lbf, 109156 kn, the 2nd of August 2016. -1B Boeing 737 MAX 23,00028,000 lbf, 10120 kn, the 22nd of May 2017. -1C Comac C91927,98030,000 lbf, 124.51334 kn, the 28th of May 2023. 1. The LEAP-1A installed on the Airbus A320neo family. 2. The LEAP-1B installed on the Boeing 737 MAX. 3. The LEAP-1C is the exclusive engine option for the Chinese Comac C919. Specifications, edit. The LEAP family. Model LEAP-1A, LEAP-1B, LEAP-1C. Configuration twin spool, high bypass turbofan. Compressor 1 fan, 3-stage LP, 10-stage HP. Combustor second generation twin annular, premixing swirler combustor, TAPS 2. Turbine 2-stage HP, 7-stage, 1B, 5-stage, LP. OPR 41, 51, top of climb. Cruise TSFC 0.51 pound/lbf/h, 14.4 g/kn/s, 0.53 pound/lbf/h, 15.0 g/kn/s, 0.51 pound/lbf/h, 14.4 g/kn/s. Fan diameter 78 in, 198 centimeters, 69.4 in, 176 centimeters, 77 in, 196 centimeters. Bypass ratio 11:191:11:1. Length 3.328 m, 131.0 in, 3.147 m, 123.9 in, 4.505 m, 177.4 in. Maximum width 2.533 2.543 m, 99.7 100.1 in, 2.421 m, 95.3 in, 2.659 m, 104.7 in. Maximum height 2.368 2.362 m, 93.2 93.0 in, 2.256 m, 88.8 in, 2.714 m, 106.9 in. Weight 2,993,153 kg, 6,592 6,951 pound, wet, 2,780 kg, 6,130 pound, dry, 3,929 3,935 kg, 8,662 8,675 pound, wet. Maximum takeoff thrust 143.05 kN, 32,160 lbf, 100